Assalamualaikum warahmatullahi taala wabarakatuh and hi. Today I will be presenting on the topic linear programming in event management. This presentation focuses on how we can use linear programming to manage and optimize resources when planning a wedding event. Efficient resources allocation is a very important part of operation management, especially in event planning, where we must balance space, cost, and customer satisfaction. According to GeoMaths, linear programming provides a systematic way to make decisions under constraints. It helps us find the most profitable or cost effective solution. In this study, we look at a wedding hall owned by Mr. Firdaus who needs to decide how many sets of tables to prepare for a wedding. His goal is to apply linear programming to find the best number of each table set that give the highest profit while meeting all the restrictions. To begin, let's understand the problem in more detail. There are two types of table set in the wedding hall, which is set A and set B. Set A is used for the families of the bride and groom. It has one table and six chairs. This cost to set up is Rm 300 and it earns a rental income of 340, giving a profit of Rm 40 per set. For set B is used for regular guests. It has one table and four chairs. It costs Rm 200 and earns a rental income of Rm 220. So the profit is Rm 20%. The challenge for Mr. Firdaus is to decide how many of each set to prepare in order to maximize his total profit, while still following certain limits such as space, budget, and seating capacity. Next, we move to the constraints and goals related to the wedding hall's resource allocation problem. So, we have five constraints involved here. First, total number of seats must be between 230 seats. Total number of tables must be between 30 and 50. At least 10 sets of set A are required. 4. The number of set B must exceed the number of set A. 5. The total purchase cost cannot exceed Rm 12,000. In this part, we define our decision variables. Let X represent the number of set A and Y represent the number of set B. All variables must be non-negative integers because we cannot have a fraction of a table set. According to Miller, linear programming assumes proportionality, additivity, and divisibility. However, when integer conditions are added, like in our case, the model becomes an integer linear programming problem. Integer linear programming models are very common in logistics and event management because they deal with real-life items that come in whole quantities. The main goal of this model is to maximize the profit. The profit function can be written as P equals to 40x plus 20y, where 40 and 20 are the profits from set A and set B, respectively. But of course, we can just choose unlimited tables. There are several constraints, such as the available space, the total budget, and the minimum and maximum number of seats. So, the task of linear programming is to find the combination of x and y that gives the highest profit while satisfying all these conditions. After forming the equations, we can represent the constraints graphically. Each constraint line divides the graph into possible and impossible region. The feasible region is where all the conditions are met at the same time. Then, we test the profit at each corner point of the feasible region to see which one gives the highest profit. This process helps us visualize how linear programming works in a simple and logical way. Here are several points we test. So, we have five intersection points, which is point A, B, C, D, E. At point A, using 10 sets of set A and 30 sets of set B, we get the profit RM 800. At point B, with 20 sets of set A and 30 sets of set B, the profit is 1,400 ringgit. Points C, D, and E were also tested, but unfortunately, they are either invalid or give lower profits. Through this analysis, we can clearly see which combination of tables brings the best results. The optimal solution found through linear programming is 20 sets of set A and 30 sets of set B. This combination gives the maximum profit of RM 1,400 ringgit. This result demonstrates how mathematical models, like in programming, can help small business owners make better decisions. It shows that event planning is not only about decoration or creativity, but also about efficient and profitable management. Now, let's analyze the constraints that affect the final solution. First, the budget limitation. Set A is more profitable, but also more expensive. So, the budget restricts how many of these sets we can buy. Second, the quantity constraints. There is a rule that the number of set B must be greater than the number of set A. These restrictions make the problem more realistic and help us see the balance between profit and practicality. To conclude, the study successfully applies linear programming to solve a real-life resource allocation problem in event management. With a total budget of 12,000 ringgit, the best configuration is 20 sets of set A and 30 sets of set B, which gives a maximum profit of RM 1,400 ringgit Malaysia. This shows that linear programming is not only used in big industries like manufacturing or transportation, but also in small scale businesses such as wedding hall operation. It helps decision maker like Mr. Firdaus achieve the most efficient and profitable use of resources. Thank you.